Air forces have always attempted to reduce the vulnerability of their aircraft by making them less visible. The traditional method to conceal them from enemy eyes was camouflage painting. However, since the development of radar in World War II, aircraft can be detected from hundreds of miles away. Radar can also be used to guide deadly anti-aircraft missiles with pinpoint accuracy. Stealth technology tries to camouflage aircraft from radar, just as camouflage paint was designed to hide aircraft from enemy view. Radar works by projecting a focused beam of electromagnetic radiation, which bounces off the aircraft back to its source. This reflected energy determines what the radar can and cannot see. As soon as radar was developed, so began the efforts to thwart it. Bombers would drop thin strips of aluminium foil called chaff. These strips, carried by the winds, formed huge clouds on enemy radar screens, making it impossible to determine the precise location of the attacking bombers. By the 1950s, technological advances allowed radars to see through the obscuring clouds of chaff. Electronic jamming equipment was soon developed to disable enemy radar by overwhelming the reflected radar signal with a stronger false signal. But every new technology triggers a countermeasure. By the 1970s, jamming could be evaded by new frequency-hopping radars. A strange little missile of the early 1960s suggested another approach to avoiding radar detection. The Quail decoy missile highlighted that the visibility of an airplane to radar was determined as much by its shape as its size. Certain shapes, such as 90-degree corners, concentrate radar signals and reflect them strongly. The Quail exploited these features so that it would appear as large as a B-52 bomber. The B-52 bombers could launch several Quails on false headings, confusing the enemy as to the size and location of the real bomber force. As it was shown that the shape of an aircraft could vastly increase its radar signature, so began the hunt to achieve the opposite effect, an aircraft that would appear smaller or even disappear from radar. This search led to low observability technology called stealth. One of the first aircraft to feature stealth technology was the Firebee unmanned reconnaissance drone. Surfaces that reflected radar strongly were hidden deep inside the airframe. This robot spy plane also included a new type of material for its skin called RAM, meaning radar absorbent material. RAM soaks up radar energy like a sponge, making aircraft virtually invisible to radar. In 1966, another spy plane appeared in the US Air Force, the legendary Lockheed SR-71 Blackbird. The SR-71 was one of the first manned aircraft to employ stealth technology. Although the Blackbird was not invisible to radar, its use of radar-absorbent material helped reduce its visibility. Another example of low observability technology is the B-1B Lancer bomber. The original, the B-1A, had a radar cross-section of 10 square meters, 10 times less than that of the older B-52. Advances in radar-guided missiles led to the B-1B. The B-1B version has a radar cross-section of about 1 square meter, 1/100th that of the older B-52 bomber. The success of the B-1B program proved that stealth technology could greatly reduce an aircraft's visibility to radar. But the challenge remained to design a plane that was virtually undetectable. In 1978, the United States Air Force contracted Lockheed Aircraft to begin the design of a stealth strike fighter codenamed Senior Trend. Unlike the SR-71 or the B-1B, the Senior Trend was designed from the ground up with low visibility features. Tests had shown that by carefully shaping the contours of the fuselage, the aircraft's radar cross-section could be reduced dramatically. This resulted in the very unusual shape of the Senior Trend, later named the F-117A Nighthawk. Although the F-117 appears unique, its novelty is only skin deep. To accelerate development of this revolutionary design, the Nighthawk integrated systems from a wide variety of military aircraft. The F-16 Falcon's flight control system, the ACES-2 ejection seat used in the F-15, F-16 and A-10, the environmental control system of the C-130 Hercules, and the GE-404 engines as used in the FA-18 Hornet. The use of ready-made technologies not only allowed the program to remain secret, but also provided the designers with a track record of reliability and maintenance performance. Before the F-117 was officially named the Nighthawk, its engineers and test pilots referred to the awkward aircraft as cockroaches, since they went into hiding during daylight. Although this name is still sometimes used, by 1983, when the first stealth fighters went into service, the pilots quickly dubbed them the Black Jets. The nickname Black Jets stems from its special black paint finish, codenamed Iron Ball. This type of paint helps diffuse radar reflections. Each minute detail of the F-117 was carefully thought through to minimize radar reflection. Because engine fan blades are easy to detect, the Nighthawk's engines are buried deep in its fuselage. Its air intakes are covered by a special grille that reduces the reflection of radar energy. Another common cause of strong radar reflections is the cockpit. On ordinary aircraft, the radar travels through the plexiglass canopy and reflects off the many objects inside the cockpit. On the F-117, the canopy is coated with a special metallic material, which prevents the radar from entering the cockpit. An additional source of strong radar reflection is the wing-mounted missile pylon. So on the Nighthawk, the missiles are carried inside the aircraft in a special bomb bay in its belly. Even ordinary straight panel lines can reflect radar energy. To minimize these reflections, the majority of the aircraft is covered with special RAM. Where panel lines remain, such as here around the night sensor on the nose, the panels have a sawtooth edge to better disperse the radar energy. Although the F-117 is classified as a fighter, it was designed primarily for ground attack missions. Most strike fighters use radar to locate their targets, but the use of radar gives off an electronic signal that can be detected by an enemy force. The Nighthawk, therefore, uses a thermal imaging night sensor. The thermal sight picks up the temperature difference between objects on the ground and provides the pilot with a ghostly video image of the Earth below him. Ground attack missions have always been the most dangerous aerial operations. The Nighthawk was developed specifically for these missions. Its speciality is the most